everyone. So now that we know how to solve quadratic polynomials, we are now going to graph them. Okay, so start by, let's just do a review of factoring. So pause the video and factor. So notice there's an x in every term here, so I'm going to divide out the x, and I'm left with x cubed minus 3x squared minus 10x plus 24. That is not factorable, so I'm gonna use synthetic division. So we got 1, -3, -10, 24. All right, let's see what we get. All right, so I got 2 works. So that means I get x minus 2, x squared minus x minus 12. So x minus 2, x minus 4, x plus 3, and then don't forget I divided by x to start. So that is my factored polynomial. All right, think back forever ago, feels like. How would you graph f of x equals x minus 5 times x plus 2? Right. That's a parabola. So what would that look like? So if I set this equal to 0, I know my roots are 5 and -2. Right? So 1, 2, -2, and then 1, 2, 3, 4, 5. And I just said sketch it. There's no negatives in front, so it's going to be upward facing. So it's going to look something like that. If I wanted to go a little farther, I could find the vertex halfway between 5 and -2. That would be 3 halves, so 1.5, and then plug in. But this is really all I was looking for, right? So it's upward facing. There's no negatives in front, and my roots are 5 and -2. Okay, so if this is my polynomial, x minus 2, x minus 8, and x plus 5 times x plus 5, what information about the graph do I know really quickly? Thinking about what we just did. I know my zeros, right? I know where this thing is going to cross the x-axis. My zeros are going to be 2, 8, and -5. So I can graph that 8, 2, -5, and try to put it so it's semi-accurate. If you want to put all the dashes, you can. I'm not going to. Now, this is one exponent up from a parabola, so it's going to be a nice smooth curve. But here's the question. Is this thing going to look like this, or is it going to look the opposite, like this? So it's going to be one of the two. So I want you to think about the equation and which one makes more sense. Would it be going up on the right or down on the right? All right, so if I think about what's happening as x gets really, really big, when x goes this way, right? If I plug in a positive number into the equation, if I plug in 1,000,000, that's 1,000,000 minus 2 times 1,000,000 minus 8 times 1,000,000 plus 5. Is that a positive or a negative? That's a ridiculously large positive number, right? Now, if I plug in a negative 1,000,000, right? Negative 1,000,000 minus 2, negative 1,000,000 minus 8, negative 1,000,000 plus 5. That's a negative times a negative times a negative, which is a negative. So my y value on the left side, as x goes negative, my y. So the answer is the green one. So my graph is going to be the green equation for this one. So what we're going to do is we're going to look at our zeros, and it's called end behavior. As x gets really big, it's going up. As x goes really small, it's going down. All right, so end behavior of a polynomial describes what is happening to the y value of the polynomial as the x value gets really large, approaches infinity, or really small, approaches negative infinity. Not small as in like close to 0, small as in negative. Okay, so here's my problem. I want you to pause and write down the information. So what are the zeros? So very quickly, you should be able to figure out what the zeros are. So my first one, I have 0, 0. I have 3, 0. Switch the sign. Negative 8, 0. And 1, 0, right? Negative 1, 0. We're setting each of those equal to 0 and solving. What is the y-intercept? What do you think the y-intercept is? Well, if the y-intercept, we plug in 0, what do we get? 0 times negative 3 times 8 times 1 is just 0. And then the end behavior. As x approaches infinity, what's happening to our y? So end behavior, our answer is always infinity or negative infinity. So as x gets really, really big, are we going to a positive or a negative? So this is a positive times a positive infinity. A positive minus 3 is still positive. A positive plus 8. A positive is not, like we're talking giant numbers, right? 1 billion minus 3 is still pretty close to 1 billion. So we get positive infinity. Right? So as x is going to the right, y is going up. So I like to think of it like that. It's going up. That's not much of a diagonal. It's going to be going up like that. Right? As x goes to negative infinity. So as the x is going negative, what's happening to the y? So in this case, we have a negative times a negative, right? Negative times a negative times a negative times a negative. So if we have, imagine again, negative 1 billion. Negative 1 billion times negative 1 billion times negative 1 billion times negative 1 billion. What's happening there? It's positive because there's 4 of them this time. A negative times a negative times a negative times a negative. Those end up canceling out. So as x is going to the left, my y is going up, right? As x is going negative, right? Negative x is on the left. My y is going up. So we've got our 0, 0. I've got my 3, 0. So 3. Negative 8, 0. And negative 1, 0. So again, because this is a polynomial, it's going to be a nice smooth curve. On the right side, right, as x goes positive, my y goes positive. As my x goes negative, my y goes positive because it's even. So I always put my arrows on the end, and then I'm just going to draw a nice smooth parabola through it. Now, one thing with parabolas, the farther away these are, the lower it's going to go. So notice I went down lower here, and I didn't go as high here, right? There's 7 between there, so it's going to go lower. Here there's only 1, and here there's 3. So I kind of try to draw it accurately in that respect. Okay, same idea. Pause and try it on your own. All right, so my zeros are negative 12, 4, and 1. My y-intercept, so I'm plugging in 0. So negative times 12, negative 4, and negative 1, which is negative 48. My end behavior as x goes to infinity. What's happening to my y? So for positive, I have my negative times a positive times a positive times a positive. The negative, that's the negative in front. Don't forget that. So I get negative infinity. As x goes to negative infinity, I've got a negative times a negative times a negative times a negative. So that's going to be a plus. So I'm going to plot my zeros. So I get negative 12, 1, and 4. And my y-intercept was negative 48. Not very accurate in terms of, well, the scales are just different. All right, so I got doot, 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 and doot. So as x is going to infinity, so as x is going to the right, my y is going down. As x is going to the left, my y is going up. So I start with my arrows, and then I just go through. That is really terrifying. Sorry. Okay, so make sure, a lot of students will try to make the negative 48 their vertex. It's not. It's going to go through that. The vertex is pretty close to halfway between negative 12 and 1. It's not exactly like it is with a parabola, but it's pretty close. So don't treat the negative 48 as your vertex. All right, same idea, but now we have to actually factor. So pause the video, factor. All right, so I got x squared. This is actually factorable. I don't have to use guess and check. Minus 9, x minus 5. All right, so I get x plus 3, x minus 3, x minus 5. Okay, if you did synthetic division, you need to check for grouping before you do anything else. You do not want to do guess and check unless you have to. It'll be this is the first day of this. I'm not going to give you guess and check now. All right, you should be doing actual factor by grouping. It's good practice also. All right, so my zeros, plus or minus 3 and 5. Sorry, I'm getting lazy. Y-intercept. If we plug in 0, what do we get? So if I plug into the original, it's just 45. X approaches infinity, y approaches, x approaches negative infinity, y approaches. Now this one's actually a lot easier. So what I do with the end behavior, it's easier to use the unfactored version. So if you just ignore the rest of it and just use the leading term, a positive infinity or a giant number to the third is still a positive giant number. A negative to the third is still a negative. I mean, you could think of it as a positive times a positive times a positive, but if it's not factored, it's easier to just use the leading term. All right, so we have 5, 3, negative 3, and 45. Those are my dots, and then my end behavior. As x goes to the right, y is positive, so it's going up. And then as x is going to the left, my y is going down. So I got that. I think because this is negative 3 and 3, I think this is the vertex. I'm not 100% on that. We can make it like that if you want. I always get confused as to where the vertex is really hard to find when it's a polynomial. It's not like with a parabola where it's always in the middle. It doesn't work like that. All right, last one. Again, this is factorable. Don't try to do this in your head. Don't use guess and check. Factor this. All right, so this is factoring. And this is good practice for the quiz also if you haven't taken it yet. This is factoring using known methods. So x squared, what multiplies to 36, combines to negative 13, minus 9, and minus 4, which is then x plus 2, x minus 2, x plus 3, x minus 3. So my zeros are plus or minus 2 and plus or minus 3. Y-intercept is just 36. As x goes to infinity, y goes to x to the fourth, and positive number to the fourth is a positive number. X goes to negative infinity, and negative infinity to the fourth is a positive number. All right, so we got 1, 2, 3, 1, 2, 3, and I forgot 36. 36. So we got 2, 3, negative 2, negative 3. So these are both plus, or both going up, so it's going to come down. Okay, go a little higher. again, I think it goes exactly through 36 as the vertex. Because of the way that these numbers are, I think it's symmetric. All right, and that's the lesson. This shouldn't have been overly hard for you. I hope you found this easy. We'll talk about it again in the next class. Have a fabulous day, everyone.